I will mention the current version of SAFIR and then new features in the next version of 2024 and the new capabilities we introduced in SAFIR. And then Thomas will talk about the new capabilities in Diamond and one slide about the support to the user community. So the current version of SAFIR is 22D5, which we released in December 23 when I visited Thomas here. And it is much more robust than the previous versions 22, especially in mechanical simulation. So you should not work with earlier versions than that. And recently, like this week, in fact, we released a version 22D7, which is available. And there are very few variations. A few bugs have been fixed. Finally, the most important one might be the first one. We recognized, or some users informed us that the thermal analysis in shell elements with localized fire, either CFD, ASEMI, or Locafi fire, were not working anymore. So this has been restored. Then a few minor bugs which would, in some cases, prevent the simulation to run. And we added a few new checks about the values that the user introduced. But what you have to know is that there is no modification in the results compared to the version 22D5 that you may be using. Maybe sometimes D5 is not running to the end, whereas D7 would work. So how can you get it? If you don't have a license of SAFIR already, you can buy it on the GESVAL website. This is the one which is now offered for sale. And if you have a version 22, you can get it for free, either from the GESVAL or account, or send us an email. And now about the new features which will appear in SAFIR 24, essentially in two directions, in fact three, two in the code and the third one in Diamond. So the first one in the code is about wood material properties, especially mechanical properties. So Thomas has introduced a probabilistic model where the reductions of mechanical properties are probabilistic. Another one where you can change the residual properties after cooling. Standard model is from Eurocode 5, but it's still under discussion. Maybe some people don't agree with that. So these two are for research purposes, but maybe more practical is that so far the mechanical model of timber was fragile. As soon as you reach the tensile strength or the compressive strength, the stress drops to zero. And Thomas has introduced the possibility now to introduce a plastic behavior in compression. And it's optional. You are not obliged to do so. If you keep this parameter blank or empty, the model will be as before. But you can define the extent of the plastic plateau, epsilon Cu, here on the graph. And the next slide will show you only two examples on an ISO fire test made on the two laminated timber column, in fact repeated twice. And the test gave 55 and 58. If we model that test with fragile behavior, we get 40 minutes. I have to say that this result was obtained with nominal values of the strength and also for the thermal properties, where it's not easy to know what's the strength of the material of the column is. But anyway, what you can see is that if we go to the plastic model, introducing a 5% plasticity in compression, the result goes from 40 to 49 minutes. So that can make a significant difference. And you see the curve showing the evolution of the displacement as a function of time. We used to have the red curve with the fragile model, and now we got the blue curve compared to the experimental one. And the second development was in a void, the cavities in 2D thermal models. And we introduced, in fact, a new algorithm to compute the view factors. The new algorithm is based on the ray tracing algorithms, ray shooting. So if you look at this example on the right side, you don't have to know what that is, but it has 6 voids. And the CPU time for calculating the view factors was reduced from 26 to 1 second. Okay, 26 seconds is not long, but in bigger voids, sometimes it's quite, it may take a few minutes, and it has been significantly reduced. But not only is it faster, but it is also more robust. if you look at these results from SAFIR 22, you know that the sum of all the view factors from one surface should be 1. And see, it was not exactly 1, sometimes a little bit less, sometimes a little bit more. Now with the new algorithm, we got a 1, and also the old algorithm, sometimes it would crash. Now it worked very well. And then also we observed a weird behavior in a model. You see at the corner, which you see here, a cold spot which has no reason to be there. It's obviously not correct. And if we plot the evolution of the temperature at that node, this is what we get. So we observe that after something like 500 seconds, we start seeing oscillations, and the simulation stops after 1,600 seconds. This problem does not propagate in the model. And the reason is that we have the oscillations with the temperature in the corner is sometimes too high, sometimes too low, but in the average, the trend is more or less okay. So, of course, the first thing we did was to apply the new algorithm for view factor to the same problem. And still we have this problem at the corner. This is now the blue curve. You see that the oscillations appear a little bit later, and the simulation goes a little bit further, but still we have these oscillations which really should not be there. So we have introduced something new. In fact, there are some terms in the equations of heat transfer by radiation which were neglected, and it worked pretty well in quite, let's say, ordinary openings or quite ordinary voids. But now we have introduced these new terms, additional terms, which forced us to use a non-symmetrical solver. And this is the green curve. You see now no oscillation, and the result is here until 40 minutes, but it could run for 60 minutes without any problem. And also the number of iterations is less, it's reduced. So it's, we think, a significant improvement. And then in the future, we want to introduce cavities in 3D models, which is not the case in the 2022 version. We have coded the algorithm to compute the view factors. It's okay, also based on ray shooting. And we hope this would be ready for this SAFIR Day, but it's still under testing and debugging. It's quite complicated. And you see the things we are doing. We're checking radiation from a triangular facet to a triangular one, from a rectangular to a rectangular one. And here you see a cube where the mesh is visible and the solid is transparent, and you see inside also a cubic cavity. This is what we are working on at the moment, and we hope to show you more spectacular pictures in the future, and we hope to release the 24 version soon. And this is for me. So now I think Thomas is coming.
Now I'm going to talk about new capabilities also upcoming in SAFIR 2024, but which have to do more with the post-processing and visualization of results in Diamond 2024. So as you may know, a big improvement modification in SAFIR 2022 was the effort on the preprocessor and moving from proprietary software JIT to the open source GM SAFIR, which is in Python, open source, based on GMSH and so on. And so for the next version of SAFIR, this time we moved lots of effort to the post-processing capabilities. And here I must acknowledge the contribution and recoding by Bruno Guillaume from Effectis France, who was the developer of these capabilities in Diamond. So the next SAFIR will incorporate just computation and printing of more outputs that will be readable by the next Diamond, which will be released together with SAFIR 2024. And here on this slide, you see just a preview of lots of new features. It will be possible to have a split window in Diamond where you can plot results on the same structure, but different types of results independently at different time steps and so on. And some of these results, you may wonder what they are because they were not in previous versions. So I'm going to go over them one by one. So in structural models with beam finite elements, one really big improvement we are very happy about is that we will now be able to plot section contours on the elements. So you can see here, it's a bit light gray, but you see those eye-shaped, beam sections, the steel beams on the all the purple beams in the model. and you have square reinforced concrete sections on the columns. So previously, in diamond up to 2022, you only saw the line elements or the beam finite elements, but now we can show the section contours in order to check the section type, to check the orientation as well of the profiles. So if you are looking at a model which combine beams and shell finite elements, that may be even more interesting, more powerful. Up to diamond 2022, here is what we could see. In green and red, you have the node lines. So these are the lines that go through the nodes, right? And you have the shells as well that share those nodes. But you couldn't see any thickness or really section geometry. Now in diamond 2024, SAFIR 2024, you will be able to visualize the section of the beams as well as the thickness of the shell. And in this example, we are showing a probably incorrect case where all those members would intersect at their geometric center. So basically, they share the nodes at the node lines. And in the thermal model, they would all be centered with the 0, 0 of the coordinates at the geometric center. So you see here the slab that goes through the center of the primary beams, for example. So it would be much easier now to detect that that is not the situation we want. And if you're a SAFIR user, you know that we offset members using the node line. And so, for example, you would offset the beams under the slab, changing the node line in the beam section types, and you would now visualize it like this with the new diamond. By the way, you can see also that this is plotted after a certain time in the calculation, and you see some rotation of some of the beam members. Okay, so they are plotted here in the deformed configuration. Note that in another type of structure, depending on the connections, on the continuity of the slabs, etc., on where the forces go through and where the members intersect, you may want to have a situation where the node line goes through the center, geometric center of the primary beams, and it is the slab that is offset above the node line and above the beams to sit on the flanges. So that is also something we can do in SAFIR, and that is not something that will be easier to check and visualize in the model. A minor modification, but we will now show the node line, this position of the node line in the 2D thermal model as well, in the new diamond. So that accompanies the previous slide. Here is a case where the node line is at the center of the primary beam, which is as shown just on the previous slide. But you could edit that node line and move it above if you wanted it to be at the level of the slab. Other new visualization features with beam finite elements, we can now show displacements with a color scale. You can define the color scale and the scale and the values of the displacement with the red and blue, and easily identify the elements that exhibit the largest displacement. You can plot these either on the initial configuration or on the displaced deformed configuration if you want. Similarly, with forces and moments, we were already able to plot these as a diagram, but now they can also be plotted with a color scale, and again with customized scale and possibility to plot on the deformed shape. Other new type of result that was not present in previous versions, we can now plot velocity and accelerations of the nodes with a scale that again can be chosen. And so what you see here, if you look at the 3D view at the bottom left, we have this 3D frame structure, and we are showing the vectors of speed or velocities of the nodes at the end of the simulation. So if we look at the top view and we go just 1 second before the failure, we see that the velocity shows that what seems to be initiated is a lateral failure mode, and we have maybe some lateral displacement and outward failure of the frame. But at the next time step, where we have much larger displacement and it's really failure, we see a significant inward displacement here and inward failure, still with some lateral displacement. But there are many cases where we are interested in the failure mode. And of course, as a nonlinear finite element software, SAFIR usually will stop at some point in the failure, right? With this vertical asymptote kind of behavior. But now with the velocity, it will be easier to understand really the displacement rate and the failure mode. And if we have to design for inward failure, that can be useful. Other feature, it's possible now to plot temperatures in the beams on the structural model. So, of course, temperatures are computed across the section. They vary in each fiber of the section. And you can, of course, plot the cross-section and the temperature gradient. But what can be visualized here is that on the 3D structural model, you can ask to show some values of temperatures. So with these kind of quantities, and I'll show something similar with shells later, we have a lot of outputs of results at each integration points of the element, because there are lots of temperatures across the thickness. So we have to make a decision on what we want to represent. So the user here has the choice of plotting either the minimum value, the maximum value, or the mean value of the temperatures across the section. So on this example, it's not particularly spectacular. You see that the beams are hotter than the columns. Remember, the columns are concrete sections, so it makes sense. But in very large model with localized fires, if we think about the big timber structure for the aquatic center of the Olympics that we've seen earlier, it could be very useful to spot the hot spots in the structure, as well as look at the temperatures at the last converged times. More on the visualization of temperatures and talking about localized fires, we can now see the fire area as well as the area of the disk under the ceiling in Hazemi localized fire. So you now can visualize position of the fire and size of the fire in your structural model. When working with shell elements, you may know that for concrete, we have a sophisticated model that incorporates damage, plasticity, transient creep, and so on. It's been used quite extensively when we model tensile membrane action and so on. But up to now, those internal variables of damage, plasticity were not represented or not plotted in Diamond. Well, in the next version, it will be possible to plot them. As I just explained for the temperatures, we have lots of damage and plasticity values for each integration, for each element. So here the user can plot either the max or the average. And we already have some nice, we have made nice use of this functionality in a current project on which Jean-Marc is working on, one of my PhD students, where we are modeling full-scale fire tests on composite floors conducted at the NIST. And in some of these tests, there was major cracking and flame pass through, and we could find very good agreement with the lines of maximum damage here along the beams. And we saw this is a nice indirect representation of cracking, since SAFIR doesn't have a discrete crack opening, it's continuum damage mechanics. But now with the damage, we can indirectly see those cracks. Finally, some more minor things, but in working on Diamond 2024, there will be also some fixes of some bugs that had been noted over time. For example, in 3D solid models, the contour did not appear well, or rather all elements were shown. Now it will be fixed. So that will also facilitate 3D thermal models. And there were some bugs in some other visualizations. So just in terms of how results were plotted, that will be fixed. This concludes the presentation of new functionality on SAFIR 2024. So we are excited about improvements in the wood material model, the void 3Ds, the acceleration of void 2Ds cavities for thermal models, and then all those visualization results for Diamond. So here I have one last slide on resources and support to the user community. So this wraps up our presentation of new developments and upcoming features. And for SAFIR, I'll just end in mentioning that we are still very dedicated in developing the software and adding new features. Thank you, and we'll now take questions.